This video is going to show you how to set up an aliquot tube. When we collect a specimen within 2 hours of collection, we have to remove the plasma or serum off of the cells and get it into an aliquot tube. Because don't forget, the cells are still alive and metabolizing and utilizing some of the things in the serum we might be trying to test for. So we got to get that removed within 2 hours. So depending on the tubes we're doing, we got serum tubes and plasma tubes. So I'm going to go over this one first with you. This is a gold top SST, serum separator tube. This tube, when you spin it, this gel starts at the bottom, and when you spin it, it goes up on top of the cells. And so I get serum on the top because you let this tube clot before you spin it. So when you let it clot, you end up getting serum on the top and cells on the bottom. The bottom also contains not only the red cells, but the white cells and the platelets. And when you let it clot, all the clotting factors get used up in this clot down here. So this is serum. This is going to be your red cells, your white cells, your platelets, and even your clotting factors. And then right here, this is your gel layer. So the first thing we're going to do is we're going to make a label for our aliquot tube. So I've got a piece of paper here, and I'm going to take the tube, and we're going to copy the information off of the tube. So 5 pieces of information are required on every aliquot tube. The name, last comma first, the medical record number, the time and date of draw, and the phlebotomist initials. Then there is a 6th piece of information we have to do, and we have to tell you the person that we do this on here, we have to put it on the label. Is it plasma, serum, or urine? So you can see when these come off, they're gonna look awful lot alike. This is serum, this one's plasma, but once we take it out of these tubes, we're not going to know. So that's why we have to add it. So I'm going to copy this label, last name, first name, last name's Moto, first name's Hashi. MR number is 413232. Now on this tube, you can see we have the date of draw is today and the time was 1 hour ago. So because in our lab, we reutilize these labels signs time after time. So when you see this in our lab, take it from the time that we make the label. So it's always the time and date of the draw, not of the time we're processing it. So today is 2/7/24, and the time is now 1:05. So this was drawn at 12:05. And then the phlebotomist's initials, MAT in this situation is our phlebotomist. So I'm going to write M-A-T, and now don't forget that last piece I have to write is an S with a circle, because I told you, right, this is a serum tube. This is serum separator tube. I let it clot, so therefore I have the serum on the top. So I'm going to take this label, and I'm going to put it on my aliquot tube. We always put the label's last name on the top of the tube. The reason we do this is when we have racks and racks and racks full of tubes, oops, I can pull those out, set those aside. Racks and racks, I can see who that is. If I had this tube upside down, I'd only be able to see that much and I wouldn't be able to tell. So when I have racks and racks of tubes, we always want the last name up on top. So you can see when we label this, I can also tell I have the label here, I have the yellow showing on the tube, and the last name is up on the top by the lid. So when I open these tubes, I'm doing it behind my protective glass. I'm going to put my barrier, my little orange biosquare over the top. This is going to help prevent aerosols from getting out if there are any aerosols, because remember these vacuumtators are under vacuum. So I'm going to put this over the top. I'm going to twist it off, and I'm just going to let it sit right there on the BioWipe, because when I get to that, I'll need to put it back on this tube. So this one, I can pop the top off of this tube and I can set it right down there. And then what I'm going to do is I'm going to hold my tubes so I can see the openings on either side between the labels. I'm going to take my transfer pasture pipette. I'm going to squeeze the bulb. I'm going to go in about halfway and suck it up. And then I'm going to put it into the other tube and I'm going to expel it out. Each time you go into this tube, you go about halfway. And the reason we do this is so getting you in the practice, because when we get to the point without the gel, we don't want to hit the gel. Once we hit the gel, it's done. But we get without the gel, if we get cells, we have to be done. So we go halfway. Now this last time, I'm going to go the rest of the way and suck it up, but I don't want to touch that gel layer. I don't want to be touching it because I don't want that in my sample. I'm going to put it the rest of the way in this tube. The pipette can go in my waste bucket over there on my side. I can put my lids both back on. Now, before I put them in the rack, because I'm still holding both, I am going to verify that all my information is correct. Moto, Hashi, 413232, today, 1 hour ago, MAT, and serum. So all the information is correct, and I can go ahead and set this in the back. Now, this tube, this is an EDTA tube. This is a non-clot tube. This tube has EDTA anticoagulant in it. What that means is these cells down here are not in a clot. If I tip this on its side, these cells are gonna get all mixed up and I'm gonna have to respin it, and we don't want to do that. Let me show you an example. I've got an extra tube here, and you can see when you put it on its side that the cells, oh, see how they get all mixed up in there? And once they get mixed up, there's nothing I can do. So this is not clotted. So because this is not clotted, all the clotting factors are still up here in this plasma. This is considered plasma. When you don't clot, it's plasma. When you let it clot, it's serum. So this is plasma. This little white thing you see here, that's called the buffy coat. That has my white cells and my platelets in it. And then all the red cells are down here at the bottom. These are concentrated red cells. So plasma, the buffy coat of white cells and platelets, and down here are my red cells. I've already made the label for this guy. You can see J. Smith. I've got his MR number, the date and time of draw, and the initials. And then also in this one now I have P with a circle for plasma. I put an S for serum, I put a P for plasma. If it's a urine, you're gonna put a U. Because again, once we get these all put off onto these tubes, they all look alike. We can't tell what any of them are. So just like the other one, last name is always up towards the top. I'm going to take my bio wipe. You can use the same bio wipe multiple times over the tube, and I'm going to pop it off. Let it sit right there to the side. Take my white one off. Now, with this guy, it's gonna be super important to be very careful, because the minute my tip hits those cells and sucks any cells, I have to be done. So, squeeze the bulb, go halfway down, suck it up, and transfer it. Now, if something happens is this next squeeze, I get some cells, at least I have some plasma off. But we're gonna go again, I'm gonna squeeze it, we're gonna go halfway down, and pass that off. So each time I get a little more. So let's try one more. I'm gonna go in, I'm gonna go halfway again, got a little bit more, pass it off. Now, I'm gonna squeeze it one last time. Let's see if I can do this. Oh, see how I pulled up cells? Even if I try getting rid of the cells, they'll still be in the sample, so that sample's no good. So it stays in. The minute you pull up any cells in your pipette, that pipette is done, that sample is done. Get rid of my pipette. I'll put my lids both back on my specimens. These ones snap on. They both make sure they're snapped on nice and tight because we don't want them spilling. Before I put them down, I'm going to check one last time, make sure my spelling, my medical record number, my date, my time, my phlebotomist, and then this is P for plasma. So I'm gonna one more time check it, make sure it's correct. And now this tube is an aliquot tube also. If you have any questions on how to make an aliquot tube or why we call it that or what we do with it, please just let us know. We're happy to answer them for you.